Hello, my name is Ian, lead trainer at CreateLabz. Welcome to this online training course that comes with the Arduino Beginner Learning Bundle. This course will introduce you to the Arduino by teaching you how to use all of the hardware that comes with the Arduino Sensor Kit base and the bonus modules included in the Learning Bundle. The Arduino Sensor Kit base consists of a single PCB which contains a Grove base shield and many common sensors and actuators. In the first two learning modules, this kit will be ideal for beginners who want to learn electronics and programming without worrying about wires and loose connections. An Arduino Uno compatible board is also included, together with additional external modules like a relay, servo motor, and connecting wires. After gaining confidence to program the Arduino with different modules in the base kit, in the later learning modules, we are going to teach you how to use external modules with actually connecting jumper wires to the base kit. This is a natural progression and would greatly make your Arduino skills more comprehensive on both programming and electronics aspect. As with learning anything new, learning how to use the Arduino can be daunting. In this course, we have designed the lessons to be step-by-step process, progressive, and definitely fun through a series of self-contained, hands-on mini projects with each lesson building on the last one. There are 5 learning modules in this course. Module 1 is both an introduction and reference guide. It consists of 4 lessons, the first 2 lessons of which will guide you through the hardware and software to be used, in setting up the hardware materials, and installing and using the Arduino software IDE. The last 2 lessons of Module 1 will serve as handy reference guide while navigating through the mini projects. You have the option to start with Module 1 to learn the fundamental concepts first and go through the mini projects afterwards. Or you can also go directly to the mini projects starting in Module 2 and just come back or review later the relevant topics you need as you encounter them in the activities. Module 2 of this course has 10 lessons, one for each sensor module in the Arduino Sensor Kit. For each lesson, you will go through 3 activities that will help you explore the sensor module and how you can integrate it with the other module. Module 3 will get you to more advanced mini projects like drawing text and graphics to the OLED display, automating a weather forecast, developing a music dynamic light show, and making a reaction reflex game. Starting with Module 4, you will learn how to use non-Grove devices and integrate them to your Arduino. You will learn using connecting wires and integrating the Arduino Sensor Kit base with external devices. This means your hardware is not limited to what you have in the Learning Bundle, but you can extend or use other devices in your future projects as long as you know how to connect them. Finally, in Module 5, we will give recommendations on your next steps and further reading and training resources. We believe that after you complete this course, you will be able to be more creative in building your next gadgets and projects. This discussion is a general overview of the Arduino, whether we are using the Arduino Sensor Kit or not. In its essence, Arduino can be considered as an embedded computer because it has both a hardware and software. Hardware is the physical device, while software is the intelligence or logic behind it. Arduino can also be connected to input variables, so this can be any input devices. Here on the left, and on the right, we have the output variables, wherein Arduino can control different output devices. Examples of input devices are push button, a normal on and off switch, light sensor, this is a distance sensor, and other forms and types of sensors. On the other hand, on the output, the Arduino can control lights like LEDs, output a sound like for this buzzer, control stepper motor like this one, or output a display for an LCD like this. You can also link it to other systems, like you can link one Arduino to another Arduino or to a Raspberry Pi, or you can link it to Wi-Fi via this Wi-Fi module. And then there's an optional user interface if you want, but it's not necessary. Then task, there's the element of time, wherein you can control the delays, or if you want Arduino to respond in real time. This slide shows to us where Arduino belongs in the greater scheme of things. Embedded development platforms can be divided into two broad groups. One is bare metal, and the other is operating system or OS group. The OS group can be further subdivided into embedded Linux OS and RTOS or real-time operating system. So Arduino belongs to the bare metal group you see here. Bare metal means your code or your intelligence is running directly on the metal, meaning there is no intermediate operating system running that manage the code. The code is running directly on the hardware. On the other hand, operating system, there is an intermediate operating system running that manages tasks and services. The most popular one for the embedded Linux is the Raspberry Pi. Again, its competitor BeagleBone. So bare metal is used for simple sensing and controlling because you can control devices very fast. If your task is more complicated, like you're gathering multiple data from multiple sensor nodes, wireless sensors, and you need to aggregate them to a cloud server, then maybe an embedded Linux solution would be more practical. RTOS combines the best of both worlds of bare metal being fast and embedded Linux being can handle more complicated tasks. In this training, we will use the Arduino platform. Now, Arduino has produced several boards and it has many flavors. Here's some examples. Arduino de Milanov, Arduino Uno, which is the most popular one. Very similar to the Arduino de Milanov, but this one uses a different USB driver. Arduino Mega, this has more pins. As you can see here, it's also larger in size. There's also the smaller Arduinos, the Arduino LilyPad. The size of this is slightly larger than a button. And then the Arduino Mini and Arduino Nano, which have similar pinouts with the Arduino Uno here, but they just remove all other components and reduce it to this size. So if you need a smaller device or project, you can use Mini or Nano. And the difference between these is the Nano has a USB interface, the Mini doesn't have, so you still need to have an external USB converter. And there are also more newer Arduinos like the Arduino Uno version 2, Arduino Due, Arduino MKR1000, which are more advanced. In this training, we will use the Arduino Uno R3. This is the original one. And this is a compatible Arduino Uno R3. It can come in different colors. This one is black, others are blue. When we say compatible, it means that the hardware is compatible with the Arduino software. So you can use this similarly with the Arduino Uno R3, the official one. We will just give you an overview of what connections you can see with the Arduino Uno R3. First, you have the USB Type B, a USB plug over here. You can actually power your Uno using the USB. Power comes from your computer. Or you can also power it using an external power supply using this DC jack over here. If you have an external power supply, so usually from 9 volts to 12 volts. Then you have these pins, we call these pins on both of its sides. Okay, each has holes wherein there's a specific function for each pin. So this is reset pin used for resetting. 3.3 volt power pin. So there is a regulator inside. 5 volt power pin. So by the way, the USB power is 5 volts and Arduino is running in 5 volts. So the external power supply here, if this is 9 to 12 volts, so there is a converter here that converts the 9 to 12 volts into 5 volts. Then we have ground pins or GND pins. And then we have voltage in or V in. So whatever you input here, you can get also in the V in pin here. These pins over here are analog pins. So they are labeled A0 to A5. On the other side, you have digital pins from 0, labeled 0 to 13. Note that 0 and 1 have special functions where 0 is serial in, RX means receive, and 1 is serial out, which is for TX or transmit. We will discuss more about serial communications later. So digital I/O pins from pin 2 to 13. This is another ground over here. This is similar here. Then analog reference pin for the ADC or analog to digital converter reference. We have a reset button. What does it mean to reset the Arduino? It doesn't mean factory reset, but it means that if you press this button, your code will restart from the start. The operation will just restart. In-circuit serial programming, this is for more advanced programming. So this is the chip used in the Arduino Uno R3, 80 Mega 328. This can come in different forms. This is the DIP package here. Some Arduino compatible boards have surface mount one, the square one, and with a lot of pins can be here. Now, there are Arduino shields and Arduino breakout boards. What are these? These extend the functionality of the Arduino Uno. We use shields and breakout boards so that we can get sensor data or control something. Shields have similar form factors with the Arduino Uno in that they have header pins on their sides that fit on the Arduino Uno. The way of connecting shields is you piggyback them on top of the Arduino Uno because it's compatible, the pins over here. So you connect on top of the Arduino. This is a Bluetooth shield. So if you want a Bluetooth functionality, like you want to connect to your phone via Bluetooth, you can use this. This is an LCD touchscreen shield. So if you want to have LCD functionality, you can just plug it on top of the Arduino like this. On the other hand, breakout boards are boards that come in similar sizes. It can be smaller or larger than this. The way you connect it to the Arduino is using jumper wires. You see these colorful wires? These are jumper wires. And the white thing over here is the breadboard with holes where you use to interconnect these breakout boards to your Arduino. You connect the pins, the wires, to the pins on the sides of the Arduino. Now, since in this training we are using the Arduino Sensor Kit base, we don't need to wire like this because the wires themselves are internally connected already in the printed circuit board of the Sensor Kit. Later in the training, we have activities that we will use these wires. This is the Integrated Development Environment or IDE, which we will be using in order to edit our code and upload our code to the Arduino. We will have more discussion about using the Arduino IDE. That's it for this lesson. In the next lesson, we will be setting up your Arduino Sensor Kit as well as set up your Arduino IDE.